Okay.
The slides.
So I'm representing basically the science mesh from the technical perspective. I'm leading the work package basically where we create the software needed for the foundation of the service to basically support the use cases that you have seen previously. We do many things in Science Mesh. So here I just give you an example of the different areas that we work on a daily basis. We work on API and protocol design for different APIs and protocols, like the CS3 APIs for Open Cloud Mesh on the WAPI protocol. But we also have to deal with, for example, web data semantics and also with the technologies behind like gRPC and protocol buffers. So this is one area that we are dealing with in the project. We do also a lot of software development in many programming languages. For example, we do a lot on PHP for the integration application for the vendors, for uncloud and for Nextcloud. We do a lot also development in Go, as the IOP based on Riva is based on the Go programming language, but we also do Python, for example, for the integration of Jupyter Hub, and we also do JavaScript for the integration of the, for example, of the COVID vendor APIs. We also run a lot of CD and CD integrations. Basically, we have deployed and developed our own Helm charts to deploy the system as straightforward as possible. We run also a lot of integrations in GitHub, basically to make sure that the software has good quality. We also work on documentation and create a nice websites to attract people so basically they can find as easy as possible the documentation needed to deploy the IOP on the sites. And as you have seen also from the presentation from Daniel, we also work on the monitoring and insights for the platform. So we use technologies like Grafana, Prometheus, also Nagios for testing, and we are looking also for open tracing support, etc. So there are a lot of areas which maybe you're familiar with from your systems already. So there are a lot of opportunities to participate into the mesh. I will basically take just some examples of how you could participate. So the contribution process is really no nonsense. Basically, everything is on GitHub on these two repositories, on Science Mesh and on the CS3 organization. We have around 25 software repositories and around like 50 people contributing to both organizations. So it's quite active activity going on there. And if you want to participate, basically the model is quite simple. You fork the software repository that you're interested in. You create some pull requests. We discuss and we review them together, and then the code is merged. Our licensing scheme is very open, so we have everything almost in Apache 2 license or MIT. So there's really no license agreement, nothing like this. We try to basically lower as much as possible the barrier to help contributing to this project. So yes, fork, pull request, discuss, and merge. So this is our our model for contribution. Then just two examples I want to give of how to contribute for the CS3 APIs and for the IOP. So the CS3 APIs are used in various places. For example, how to connect an application using CS3 APIs. Marcin presented the use case for Jupyter Hub. So you can see the code into this repository. Then how to connect to some storage systems, like for example, S3, EOS, or some local file systems. You can take a look at the riva repository with the integrations with some of them. And then for the integration with the enterprise file sync and share systems, I have here two examples, the uncloud one and the Nextcloud one. So you can take also a look at these repositories. Practical example of how to contribute to the CS3 APIs. So we have documentation created already from the code for the CS3 APIs. So you can take a look at the repository and you will have all the documentation available there. So in case, for example, that you want to extend some functionality, let's take the case that you want to increase or expand the authentication mechanism. We support, for example, basic auth, OpenID Connect, and token-based authentication. But imagine that your system that you want to integrate with supports any type of mechanism which is not configured and is not implemented yet. So the first thing that you do basically is that every single request and response in the CS3 APIs, it has an opaque field where you can basically pass information in and out of the system. So With this opaque field, basically, you can prototype and test and validate basically your thesis about the mechanism that you want to implement. So for example, here you have an example of one of the upload requests. So for example, we want to pass the upload length. So we pass this as an opaque field. And with this, you can validate basically that your flow is working. What we do after that, we have this prototype already available and working. Let me go to the next one. What we do basically, we create a pull request to the CS3 APIs, where we add a new method to the CS3 APIs to basically avoid having the dependency on using the opaque fields. We have a really strong process and powerful process for CI in the CS3 APIs. So when you have an addition or to the CS3 APIs, what happens behind the scenes is that the code gets breathed into the CS3 APIs repository, and automatically after it's compiled, is published to different repositories for different programming languages like Python, JavaScript, Go, etc. And what is more important is that we also publish them into the basically main software repositories. For example, for the JavaScript APIs, we publish to NPM. For Python, we publish to PyPy, and for Go, we publish basically to just to the Go system. Another example is for the interoperability platform. So there is nice documentation about the IOP in the Science Mesh developers portal. So you can take a look. To understand a little bit more what is the IOP, how you can deploy it, and also the guidelines that Daniel presented of how to join the Science Mesh in the left panel. Just a quick overview. So the IOP consists of different services. One of them is the Riva service, but also contains like services like WOPI, for example, for integrating with applications, and also Arclon for doing the data transfers. It's quite easy to deploy if you are used to Kubernetes. We package this as a Helm chart, so you just run these commands and you have the IOP basically working. From a technical perspective, what is Riva basically? It's a Go server, which is ideal for systems programming basically. It's a server that opens up different protocols. Currently, we have gRPC and HTTP, but it's really straightforward to add any type of protocol that just can listen on a socket on Linux basically. So WebSockets, FTP, whatever you can imagine, you can easily add it. It implements various APIs, CS3 APIs, OpenCloud Mesh, WebDAV, OpenID Connect, many more others. It's quite also nonsense for the process management. So basically the way that the daemon is handled is really like Nginx. The documentation is even the same as Nginx, which is basically to make sure that they're really safe for production in order when you want to reload, for example, the configuration, that you don't introduce any breakage into the system. It's quite easy to run also. You have a binary, you have a configuration file, and you can basically pass a process ID, so you can reload safely. It has a lot of modules to extend gRPC services, for example, like connections to storages, connection to authentication mechanisms, and also has already plenty of modules to extend HTTP services, like for example, WebDAV, some Hello World examples, etc. So you can take a look on the repository to see what is available. Other things like service discovery, clustering, and consensus, etc. These are left to other technologies, which can do much better from what we can think, and they already know enterprise-grade solution for that, like Kubernetes or etcd. So basically, we keep it minimal and simple to basically have the minimum and the foundation for the service. There are two places basically where you can find documentation about Riva. One is the main page, riva.link, and also we are quite active on Jitter. So if you have any questions, don't hesitate to pass by and ask the question there. This is a quick example of what we do basically to enforce that the software is quality, especially as this software will be deployed in many sites. So first of all, what we do is that for any addition to Riva, basically we do a license check to make sure that the software always remains open under permissive license. So if someone, for example, wants to add a software dependency, which is HGPL, for example, this will hint us and the dependency will not be accepted. What else we do? We also do security checks, basically. So for every pull request that is accepted, We run a security analysis to make sure that the system is as safe as possible. We use the looks good to me basically platform to check for vulnerabilities, and it's quite nice because I have found already quite a good amount of them. Also, we run unit tests and linters. There are a lot of people contributing to tests, especially OnCloud has contributed with a lot of end-to-end tests for the OnCloud APIs, which are really helpful for debugging end-to-end tests. We also enforce changelog to avoid surprises when upgrading. So this comes from experience because before basically we were not enforcing that every single pull request has a changelog item. So now basically on each release of Riva, you can see basically what has changed and if there is major changes for integrating with systems. We also have commit releases. So every time a new commit is merged into the master branch, there is a new version of Riva being published, which you can access it publicly, which is built for Mac and for Linux, basically. So you can give it a try out of the box. So you don't need to build and publish yourself. It's already available for you for free. Also for Docker, if you are a Docker guy, you can also get the latest Docker images or the latest stable version from there. Just to finalize, that major areas for improvements that we want to tackle basically in the coming months are that the documentation on how-to tutorials, because they are not enough, and we see that people sometimes are struggling to know what is Riva, how they can start contributing to it, and also for the CS3APIs. So this is one of the areas that we have to improve in the coming months. Also for package distribution, we would like to publish the demos through normal packages repository like RPMs or APTs, etc. Currently, if you want to add a plugin, you need to add it at compilation time. When it goes, not a big problem because compilation takes a couple of seconds, but we see that now there are tools that can allow for runtime plugins. So you just put a repository and then the plugin will be run and check for verification in the runtime. So this is quite nice. More testing we need, and also benchmarking. We would like to introduce some benchmarking tests to stress test basically the performance of the platform to make sure that is up to the standards of the sites that it will run. And that's it, my presentation. So thanks a lot, and I open for questions.
Thank you, Hugo. So are there any quick questions to Hugo? As you can see, we have a fully professional development environment and workflow in place. Okay, so perhaps if there are people that would be interested in getting more detailed information about that part, we'll take it offline.